Good day. So today I'm going to show you how to deal with domain and range in every graph. I'm going to give you an easy method that you'll be able to use to find the domain and range of any graph. So first of all, what is the domain? So the domain are all the x values that exist on the graph. So the domain are all the x values. And then the range are all the y values. Alright, so the domain are all the x values that exist on the graph. The range are all the y values that exist on the graph. So domain is from left to right, range is always from down to up. Alright, so now let's begin. Let me show you the method. Alright, let's start. So what we're gonna do is we wanna find the domain. So if we wanna find the domain, we're gonna have to find the leftmost part of the graph. We have to find out where does the graph start. So the graph starts, the leftmost part of the graph is right at this point. So we draw a vertical line where you can see the leftmost part of the graph. So the leftmost part of the graph is this side, and then the rightmost part of the graph, where does it end? So the rightmost part of the graph is gonna be at this part. And then we have to check if there's any asymptote in between. There is no asymptote in between. So then you're gonna write down where does it start and where does it end. That is all. All right, so we'll say the domain is x is an element. So domain is x is an element. So this side means element. So we'll say x is an element. Where does it start? So whenever you see an arrow, it means there is no starting point. It means it's infinity because it will keep on going left as it keeps on going down. So that's what you have to memorize. The thing that you have to memorize is that you look at the red line, you have to check where is the leftmost part and the rightmost part. And then where the line is, where you draw, you have to check if it touches an arrow, it means there is no starting point. So it means it starts from negative infinity. And infinity always has a curved bracket. And then where does it end? You see, it will go all the way. So where does it end? It also ends at an arrow, meaning that the end part is infinity, right? So infinity always has a curved bracket. So this side, because the x values are negative, we have negative infinity. This side, their x values are positive, so we have positive infinity. So we're done. That's the domain. What about the range? Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEP, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. All right, let's find the range. So we want to find the range. Remember, domain is from left to right. Range is from down to up. So we have to find out what is the lowest part of the graph. The lowest part of the graph, if we try and draw it, the lowest part of the graph that we can see is this part. So now with domain, you draw a vertical line, right? You draw a vertical line, but with range, you draw horizontal lines. We're trying to find out the lowest part and the highest part. So the lowest part is this part. The highest part of the graph that you can see is at the turning point, so it's this part. So the lowest part, the highest part. So when you're writing your range, we're gonna say, where does it start? So range is y is an element of, you see it's an arrow, it touches the arrow, so therefore it means there's no starting point. And because we're starting from the negative place of y, it's gonna be minus infinity. And then it continues all the way until that red line, so there's no asymptote in between. There is no asymptote. So we just continue. Whenever there's an asymptote, I'll show you what to do. That's gonna come out next. So in this case, it ends at that vertical line. So the vertical line, what is the y value there? The y value is 8. Be careful of that. Don't mix the x value and the y value. So the y value is 8. So this line is y is equals to 8. So the y value is 8. So it's at 8. But now here, it doesn't touch an arrow, and the graph really does exist at that point. So it doesn't touch an arrow, and there's no asymptote, so it's gonna be a square bracket. So whenever it does not touch an arrow and whenever there is no asymptote, it's gonna be square. But whenever it touches an arrow or where there's an asymptote, it's gonna be curved. Wherever it touches an arrow, it's always gonna be infinity. All right, so there we have it. We've got the domain and the range. Alright, so now we want to find the domain and the range of the straight line graph. So I'm going to give you several examples. You will just be using one method, you will understand it fully. Alright, so in this case, we have got a straight line graph. So this straight line graph ends here and begins here because there's no arrow. So let's find out the domain. The domain, we have to find out where does it start and where does it end. So from left to right. So we're going to draw vertical lines. So let's begin. So where does it start? So it starts at this point because it doesn't go further than this point. So therefore we can draw a vertical line over there. So we draw a vertical line, and where does it end? It ends here, so we can draw a vertical line, and there is no asymptotes in between. So what is the domain in this case? Where does it start? Where does it end? We'll say the domain is x is an element of, so it starts at -2 and it ends at 2, right? Remember, domain is x values, range is y values. So when it's domain, we have to focus on the x values. When it's range, we have to focus on the y values. So, right? Then let's talk about the bracket. It's not an arrow, neither is it an asymptote. It's gonna be square. So there we have it, that's the domain. Now let's talk about the range. So now we wanna find the range. So since we wanna find the range, we have to focus on where does it start, where does it end. So remember, domain is from left to right. The range is from down to up. Where does it start, where does it end? So since we want to check down, let's check the lowest part of the graph. So we have to draw a horizontal line. So this is the lowest part of the graph. So we have to draw a horizontal line. And then the highest part of the graph, which is this part. So it starts here, it ends there. There's no asymptote in between. So what do? So we have to write the range. So the range, in this case, we're going to say y is an element of. So y is an element of. So where does it start? It starts at -4. Remember, we're looking at the y values. So it starts from -4. Where does it end? It ends at 8. And because it's neither an arrow nor an asymptote, it's going to be square. So that's what we have there. And we also have to say x is an element of real numbers. That's just what I forgot to show you, but it's nothing much. And here the range is y is an element of real numbers. Yeah, that is all. So even if I don't explain why do we do this, you don't need to know that part, you just have to memorize it. All right, so that's the domain and that's the range. All right, let's go to another example. All right, so now here is the next level. Here is a hyperbola. So we have to find out, let's say we want to find the domain, we have to find the leftmost part of the graph, and we have to find the rightmost part of the graph. So let's find the leftmost part of the graph. So the furthest part we can see on the left, in this case, is here. So if we draw a horizontal line there, and then we can also see the rightmost part, which is this side. So we draw a vertical line over there. So we draw a vertical line. All right. Now, in between, is there an asymptote? Yes, there is a vertical asymptote, right? If we draw vertical lines, we focus on vertical asymptotes. We don't focus on horizontal asymptotes. When we draw horizontal lines, we also focus on horizontal asymptotes. So in this case, because we're drawing vertical lines, we have to focus on vertical asymptotes. So since there is an asymptote in between, it means the asymptote cuts this thing into 2 groups. So when we write this, we will write it in 2 groups. So what do I mean? Okay, fine, let's find out where it starts first. So remember, the starting point is at the arrow, so therefore we're gonna say x is an element of, so it starts at infinity, right? Minus infinity, which always has a curved bracket. And then now it continues, but remember it's in 2 groups, so we can't take this as 1 group. So we have to consider this group first and this group next. So it's in 2 groups. So it starts here and it ends at the asymptote. So it ends at the asymptote. So the asymptote here, the x value of the asymptote, which is 2, right? This asymptote, it has a constant x value, so which is 2. So, and then the asymptote will always have a curved bracket because the graph does not exist at the asymptote. It always has a curved bracket. So curved brackets are kind of like saying less than. Square brackets are kind of like saying less or equals to. So this is inequality notation, but this one that I'm teaching you is interval notations. So interval notation, most students find it the easiest, so hence I show you interval notation. So whenever there's an asymptote, it's always a curved bracket. Arrow, curved bracket. So, we have finished this group. So when we finish this group, we have to say or. So in interval notation, we don't write or in words. In inequality notation, where we have got x is less than, we say or. But in interval notation, we write or in the form of u, just like in probability. All right, so we're done with this group. Now let's describe that other group. So let's describe this group. So we describe that group it starts from 2 until the arrow, which is infinity. So it starts from 2 until infinity. Infinity always has curved here because it's an asymptote curved. So there we have it, the domain. All right, so let's talk about the range. Remember, domain is from leftmost part to rightmost part. The range is from the lowest part to the highest part. So what lowest part do we see in the graph? So the lowest part in the graph is this part that we see, this arrow here. So therefore, we're gonna draw a horizontal line there. And then the highest part that we see is that place where there's an arrow. That's the highest part of the graph. So, is there an asymptote in between? Yes, there is a horizontal asymptote in between, interrupting it, therefore separating it into two groups. So you see, when we're drawing vertical line, we have to look at vertical lines because the vertical line will cut it into two groups. Now, this is horizontal lines. Whenever we're drawing horizontal lines, we have to look at a horizontal asymptote because the horizontal asymptote will cut it into groups again. So, in this case, it cuts it. So then what are we gonna do here? So now in this case, we have to right, so we're gonna say the range is y is an element of, so where does it start? The lowest part where the arrow is. So it starts at infinity because it's an arrow. And then there is an interruption, right? So we have to start here, stop there. It's in two groups. So what is the y value of this? The y value of this asymptote is 1. So since it's asymptote, it's always as curved, then we have to say or. Then where does it continue? So it continues from 1 again until the arrow. So from 1 until infinity because of the arrow. And then that's what we have. So curved bracket here because it's an asymptote. So there we have it, the range. Let's go to another example. All right, then this is the exponential graph. So let's find the domain and the range. So the domain, let's find the leftmost part of the graph. The leftmost part of the graph is here where we've got the arrow. The rightmost part of the part is here where we've got an arrow. So is there an interaction? There is an interruption of a horizontal asymptote, but we don't consider it. We consider the vertical one that will split this into two groups, but it doesn't exist here. We have a horizontal asymptote, we don't have a vertical asymptote, so there's no interruption. So therefore, it's one group. So let's write the domain. Where does it start? Where does it end? Well, it starts at the arrow, which is x is an element of minus infinity. Okay, fine, I forgot to put element. So x is an element of minus infinity. And it continues until infinity because of the arrow. So therefore, it continues until positive infinity. And infinity always has a curved bracket. So we're done with the domain. All right, let's find the range. So let's find the range. Okay, so now we want to find the range. So what we're going to do is we have to find the lowest part of the graph. The lowest part of the graph is just before the asymptote, right? So we cannot draw a vertical line there because, a horizontal line. We can't draw a horizontal line there because there is already a horizontal line which is an asymptote. So if it starts at the asymptote, then you don't have to put a line. You have to leave it. So what is the highest part of the graph? So the highest part of the graph is where there is an arrow. So we draw a horizontal line there. So this is the group. So it starts from the asymptote until the, so whenever it starts from the asymptote, do not put your own line there. We consider the asymptote when it's in the middle, but if it's at the beginning or the end, we make it part of the line. We don't have to put a line. So in this case, this asymptote is the beginning. So how do we write the range? The range is y is an element of, remember, if it's an asymptote, it's a curved bracket. It's just the same as an arrow. All right, so whenever it starts from the asymptote, we do not have to put a line. So it starts from the asymptote, this asymptote will be the beginning. And then let's check where it starts and where it ends. So it starts at 0. Remember, when it is an asymptote, it's gonna be curved, right? Whenever it's an asymptote or an arrow, it's gonna be curved. So it's gonna be curved. All right, and then where does it end? It ends up the way there is an arrow, and an arrow is infinity, so it's gonna be at infinity. So then it's going to be curved. This side, it is also an arrow, but it is not infinity in terms of y, because we're looking at the asymptote, right? It's an asymptote. The graph will not pass the asymptote. So whenever you say the asymptote, to be safe, just don't put your own line. If you say an asymptote, consider the asymptote as a line, and where the asymptote is, it's where it starts. So just remember that whenever we see an arrow, it's infinity. But if we see an asymptote, it starts at the asymptote. It doesn't start at infinity. The asymptote is the beginning. So this is what we have. We have the domain and the range. The next example is for grade 12s. So if you're in grade 11, you can still learn from the next example. Yeah, but this is not going to come out in your exam, but you can still benefit from it. And then if you're in grade 12, just keep watching. All right, here is another example. So after this, I'll show you the last example, and it's going to bring us to the end of the video. So here is the second last example. So in this case, let's say we want to find the domain. Where does it start? Where is the leftmost part of the graph? The leftmost part of the graph is here, where the asymptote is. Remember, when the asymptote is the beginning, we have to start from the asymptote. And then where is the end? So the end part is this side. So therefore, we do not have to put a line at this. We do not have to put a line at this because that's already our starting point. But we do have to put a line here where the arrow is. So let's check the domain and the range. So the domain, in fact, so the domain is x is an element of, so it starts here. It's not infinity, it's an asymptote. It starts here. So the asymptote has a value, x is equal to 1. So therefore, we're going to say it starts from 1 and always a curved bracket by the asymptote until the arrow, which is infinity. What about the range? Okay, so if we want to check the range, what we have to do is to check the lowest part of the graph to the highest part of the graph. So the lowest part of the graph is this arrow there, the lowest part of the graph. The highest part of the graph is the arrow again. So is there an interruption? There is no interruption by the vertical, by the horizontal asymptote. There's no horizontal asymptote. There's only a vertical asymptote, which we do not consider it in this case because we're drawing horizontal lines. So let's talk about the range. The range is y is an element of, so it starts from the arrow, which is minus infinity, and it ends at the next arrow, which is positive infinity. So there we have it. But remember, we still have to tell them that x is an element of real numbers here, y is an element of real numbers. I haven't been focusing on it because it's just something that will always be there. So yeah, nothing special, it will always be there. So that's what we have. So it starts from minus infinity to positive infinity. And let's go to the last example. All right, here is the last example. This is grade 11 part. So yeah, this is grade 11, grade 12 because it's an exponential graph, it's not a logarithm graph. All right, so let's find the domain and the range. So the domain, the leftmost part to the rightmost part. So where is the leftmost part? In this graph, this is the leftmost part, and that is the rightmost part. So is there an interruption? There is no interruption by vertical asymptote. We do not have a vertical asymptote. We have horizontal, which we do not consider in this case because we're drawing vertical lines, and that one is horizontal. So x is an element of, where does it start? By the arrow, which is negative infinity, and it ends at infinity, which is the other arrow. So that's what we have. Also, x is an element of real numbers. And then what about the range? Let's talk about the range. So if we have to talk about the range, we have to look from the lowest part to the highest part. So let's check what is the lowest part of the graph that you see. The lowest part of the graph that we see is this part. So it starts here. And then the highest part of the graph we see is this part, but there is already a line. Whenever there is a line at either the lowest or the highest part, whenever there is an asymptote, we do not have to put our own line. We have to make that the line. So let's talk about our range. So our range is y is an element of, where does it start? The lowest part is the arrow, which is infinity. And let's talk about the highest part. So the highest part is an asymptote, which we have to consider a value. So every time you see an asymptote, you have to consider its value. It will never be infinity. So an asymptote, you consider its value. So the asymptote part, so this is going to be at 8. And the asymptote is always curved bracket, and y is an element of real numbers. And this brings us to the end of this video. So if you like this video, please like and subscribe to my channel. And if those contacts that I provided are not, if one of them is not working, please comment below and I'll send you a new one.